Okay, does someone want to take us through how they simplified the first one?
Get rid of
Charlie?
X squared is subtracted by x, which becomes 3x over y.
Yes, so we're going to reduce 1x out of each of those. And then we have 3x over y. How about restrictions? Does anyone want to share with us what they put? Can somebody remind us what restrictions are? Let's start there. What is a restriction? Not you, Nicole. Not that Nicole. This Nicole, yes. Restrictions. What can the denominator of a fraction not be? Okay, so restrictions are produced when we have variables in our denominator, right? So if I have x times y right here, what value of x could cause the denominator to be 0 if I multiply it by y? 0. And how about for y? If I have y times x, if y is 0, then that also causes the whole denominator to equal 0, right? So we need to say x cannot be 0 and also y cannot be 0. Okay, so any variable along the way that could have caused your denominator to equal 0, you need to restrict that, even if it gets canceled out.
So if it's like x plus 3, the x cannot be a negative 3.
Exactly. Okay, second one here. Does anyone want to share with us how they reduced? Okay, well, I think we have two x's here that can be canceled out with each of the x's on the bottom. So those things cancel out one another. We can also reduce here. So remember we talked about cross-reducing when we have multiplication in between two fractions. So 3 and 12, I'll reduce that to 1 and 4. And then we can also reduce the 4 and 2 to 2 and 1. And then we'll multiply the tops and multiply the denominators. So we get 2 times 4x cubed is 8x cubed. And then 1 times 1, all that's left on the bottom is 1. So we don't really write 1 in the denominator. So it's just x, 8x cubed. Restrictions here. I have 3x in my original question and 2 times x. So what value of x would cause our denominator to equal 0? 0. 3 times 0 would cause that whole denominator to be 0, or 2 times 0, right? So we need to say here that x cannot be equal to 0. Okay. So we are going to just kind of recap here. When we have to simplify, what we said before was factored form is simplest form. So I'll say factored or common factored. Oops. Say factored. Factored and common factored form is simplest form. Also, if you happen to be able to reduce anything, like cancel any common brackets, we definitely want to do that. Okay, also we want to remember anytime we have variables in the denominator, we're going to need to restrict them, okay? So sometimes in order to simplify, we need to factor. So probably your initial step in all of these questions that we're going to be doing from here on out is factoring. So on the top, does anyone recognize this? It's a special not trinomial, but it's a special quadratic. Thomas?
It's 3 times 3, it's a perfect square.
Close. So x squared and 9 are perfect squares.
Minus 3.
Yeah, so it's a difference of squares. So we do x plus 3, x minus 3. Very good. And for the bottom, we're looking for two things that multiply to 12 and add to 7. 4 and 3, that's right. So positive 3 and positive 4. Okay, before we cross anything out, let's look at the denominator. What causes x plus 3 to equal 0? What value of x? Negative 3. And how about x plus 4? Negative 4. So those two values we want to restrict for our variable because they'll cause our denominator to equal 0. Now when you have full groups that are the same and they're being multiplied, you can actually cancel out those groups. That's a factor on the top and a factor of the bottom. So we're left with x minus 3 over x plus 4. Now, we actually touched on restrictions last week. There are two things that our restrictions could produce on a graph. What are those two things? What do these restrictions physically look like if I were to graph this function? Sheila? Yep, there could be a little hollow point. We've seen those in our travels so far. What else? What's the other thing that our restriction could produce? Thomas? Not quite. Sheila? So vertical asymptote, right? So vertical asymptotes we get, so you know like our graph kind of goes toward it and then it curves off in both directions. So we talked about those when we did domain and range. And undefined points. So last week we talked about if I can see the restriction in the final answer, like in this case we can see that there's a restriction of negative 4, that actually produces a vertical asymptote. And if it gets canceled out along the way, like our x plus 3's got canceled out along the way, I don't see it in the denominator in the final answer, this produces an undefined point. Okay, I actually just talked to my calculus class about this again today, so. Okay, so if you remember back to some of our lessons, I showed you guys on the graph and then we hovered over the point and it said undefined on it. That's basically what I'm referring back to here. Okay, so when we have multiple rational expressions that are either being multiplied or divided, I've kind of just listed out the steps for you guys here. For multiplying and dividing, the very first step is that you're going to factor and common factor everything, okay? All numerators, all denominators. We are going to write restrictions, just like we just did. And then with multiplying fractions or rational expressions, we can cancel any numerator with any denominator. You can't cancel individual pieces out. So what I mean by that is if we look back at this example, this is a great example. I don't want to simply cancel an x and an x. Okay, you can't do that. It has to be a full group that you cancel out. So notice that there's multiplication happening here and happening here. And I cancel out the full group of x plus 3 with the other full group of x plus 3. Okay, so if you go to cancel something, you're going to hear me say this like probably 20 times at least this unit. If you go to cancel something and there's a plus sign or a minus sign directly next to that, stop. Okay, you don't cancel that thing. It needs to be multiplication happening. Okay, this is like a very crucial kind of like getting to understand like what can be reduced and what can't be reduced, and we're going to carry this forward. So it's important that we get down some of these skills, right, Nicole? Okay, steps for dividing. We're basically going to do the same thing. We're going to factor and common factor. We're going to write restrictions for variables in any of the denominators. When we divide two fractions, we take the second one and we flip it, and then we change the division to multiplication. Now, if I flip the fraction, I now have another restriction, new restrictions that are in my denominator if I flip a fraction. So we'll add any restrictions to our list that we need to, and then we'll start canceling again. Okay, so remember, if you try to cancel something and there's a plus or a minus right next to it, you got to stop. Okay? All right, so let's try it out. We'll do a couple easy examples to start. So step number 1 is we are going to factor, fully common factor everything that we can. So take it piece by piece. Let's look at this numerator. What can we do with 4x plus 24? Yeah, we'll take the 4 out. We're left with x plus 6. Perfect. Okay, denominator x squared plus 8. 8x, sorry. What can we do there? There's a common x. So we're left with x plus 8. Single term, there's not a lot that we can do with that, so that one will just stay as 12x squared for now. Okay, and then 3x plus 18. Yep, we will common factor a 3. We're left with x plus 6. Okay, we never want to forget, you're going to start a little restrictions list. X cannot equal, and we need to restrict any x's in the denominator. Okay, it's a lot easier to see once you've factored. So if you try to look here, you might miss something, but it's a little bit easier to see once it's factored. So that's why we try to factor it first before we do that, the restrictions list. Okay, so -6, -8. What if it's just like a single x out here? What causes x times something to equal 0? 0. So x also cannot be 0. So whenever you see like an x that's being multiplied like in front of a bracket like that, if I were to sub in 0 here, we get 0 times 0 plus 8. That's 0 times 8. That makes the whole denominator 0, right? So we don't want that to equal 0. Okay. Great. Now you can actually just start canceling. So any full group with any other full group, something from the top with something from the bottom. Zach?
Divide the 12 into 3.
Okay, we can reduce 12 and 3 to 1 and 4. That's great. What else?
There's 2x plus 6.
There's an x plus 6 on top and bottom. Those can be canceled. Anything else?
Are you able to reduce that for an a plus it stays in the bracket? You can.
No, so this is actually a very good example of what we were just talking about. If you're tempted to reduce, look at what's next to the 8, a plus sign. We can't do that, right? Anything else? How about I have 2 x's up here and a single x down here. Can I reduce those? Okay, so we'll take out 1 from each. We'll just be left with an x on top. Okay, multiply your numerators. We've got 4 times 4x, that gives us 16x. And all that we're really left with on the bottom is x plus 8. Can I go any further here? Did we miss anything? Is there anything that can be reduced? Can I cancel those?
No.
Cameron says no. Why do you say no, Cameron? Yes, so I would have to have a full set of x plus 8, right? Again, if I go to cancel this and there's a plus sign right next to what I'm trying to cancel, I can't do that, right? I have to stop. So this is actually as far as we can go with this question. So that's fully simplified. Okay, your restrictions are also part of your final answer. Okay, well, let's look at our part B here. Okay, so you're going to go through, we're going to do step number 1. That's factor and common factor everything. So let's take a look at each piece here. X plus 1, there's not really a lot that I can do with that. 2x, that's just a single term. So again, not really much I can do with that. 2 things that multiply to 3 and add to 4. What was that? 1 and 3. X plus 3, x plus 1. Beautiful. Okay, now that everything is factored, we're just going to start a little list of restrictions here before we continue.
0.
X cannot be 0. Why, Zach?
Because if you multiply 2 and 0, it's going to equal 0 for both sides.
Yeah, 2 times 0 is 0, or 3 times 0 is 0. Thomas?
X cannot equal -3.
Why -3?
Because -3 plus 3 is 0.
So are you restricting this?
Yeah.
Okay, so we don't usually restrict tops, but this one is going to be flipped and multiplied, so we will restrict that in a second. Okay, so next step here, we're going to take the second second fraction, and we're going to change to multiplication once we flip it. Okay, so now Thomas,
Negative 3.
now we have to add a couple of restrictions, right? Because we now have just put something new in our denominators. So negative 3, and what else? Negative 1, that's right. Perfect. Now we can go and do our canceling thing. Just as a little reminder, x plus 1 needs to be canceled out with a full group of another x plus 1. If there's not another group of x plus 1, it can't be canceled. Okay? So what can you reduce?
X plus 1.
The x plus 1s. Yes, we can do that. What else? Anything?
I mean, can you do the x's?
You tell me. Can we do the x's?
No.
Are there any pluses or minuses next to them?
No.
So I can do them then, right?
I thought.
Okay, so what's left? Well, we have 3 on top, and then we have 2x plus 3 on the bottom. Okay, again, factored form is simplest form, so leave it common factored. You don't need to bring the 2 inside the bracket. Okay, keep it common factored, keep it fully factored. That's simplest. Any questions on those ones? Josh? Okay, can I scroll? Okay. All right. Kicking it up a little notch here. So guys, one really important thing to remember is when you have a value in front of your x squared, you can't factor like we factor easy trinomials, right? So you guys need to, if you need to review this, I'm going to show you one more time how to factor a trinomial like this, and then I'm going to expect you guys, like I'm just going to factor them. But I will do this one. I'm just going to do it off to the side here, and I'll erase it after. But when we factor a trinomial like this, what we would be looking for is 2 things that multiply to a times c, which in this case is 5 times 8. So 40, and add to the b value, so the center value here. So adds to negative 13. Can anyone think of 2 numbers that fit this? It's very close to what we already just multiplied here. Close. Not 5 and 8. Needs to add to negative 13. Josh? Yes, negative 5 and negative 8. Again, there's many different ways that you can factor stuff like this. The main way that probably many of you were taught is to split this middle term. So I'm going to split this into negative 5x and negative 8x, and then you do your groups. Okay? So this is like your group 1 and your group 2, and you common factor something from each of your groups. So in this case, 5x, we're left with an x minus 1. And in the second group, we take out a negative 8. We're left with x minus 1. This is what we want. We want those brackets to be the same. So we get x minus 1 and 5x minus 8. Okay, and that's factored. Okay, this is probably the longest way that you can factor a trinomial like this, but it kind of grounds the idea of like why it works the best. So if I remember, hopefully I do, I have a little video that shows a couple different methods, and if you guys are interested in learning maybe a quicker method, you can take a look at that video. Okay, so I'll try to remember to post that for you guys. Okay, so our first trinomial, 5x minus 8 times x minus 1. I'm just going to erase this now. Okay, this guy I can't really do too much with the x minus 7. I do like to kind of bracket it up just to show that it needs to be reduced with another x minus 7 if possible. 1, obviously we can't really do much with that. And then this guy here, let's see. That combination's not going to work. Maybe 5 and 2. There we go. So it's 5x minus 8 and 2x plus 1. Okay, this little method here is a nice one. It will be in the video that I post for you if you're interested in a faster method. But again, I'm not going to show that factoring, so I would expect you guys to know that at this point now. Okay, so before we start to cancel anything, x cannot equal. We need to restrict each of these brackets here. So give me 1. 7 is one of them. Thomas?
Restriction 7.
Sheila? 0 is not 1. If I sub in 0, let's say here, it's 5 times 0 minus 8. That's not 0, right?
You can, no,
So what makes 5x minus 8 equal to 0?
that's a great question. It would be,
Solve for x. Charlie? Not 8.
No.
So isolate for x, we divide out 5. 8 over 5, okay? The really nice, little quick way that you can do this is if you see a bracket like this, switch the sign, so it's going to be positive, and it's this over this. So what's the next one? It will be negative, wait, switch the sign, this over this, 1 over 2, okay? If ever you forget, set the bracket equal to 0 and solve for what makes it equal to 0. Okay, now we can cancel. So is there anything that can be canceled here?
5x minus 8. Yes.
The 5x minus 8s, anything else?
Math.
Okay, multiply the top. 1 times anything is just itself. And then on the bottoms, you do not need to FOIL. Keep this in factored form. Factored form is simplest. And we're done.
The loudest thing ever.
That was very loud. Okay, any questions on that one? Okay, let's try the next one. This is going to be basically just lots of practice to kind of get used to what we can do and what we can't do. So you're going to notice the lessons are a little bit shorter for these ones, but you guys have lots of practice questions that you can do to practice this stuff. Okay, so factor and common factor everywhere. So what can we do with this top part here? 2x squared minus 8x. Josh?
Factored by 2x.
Yes, so we're going to common factor a 2x. We're left with x minus 4. Okay, next part here. This is a trinomial, and an easy trinomial because a is equal to 1. So two things that multiply to negative 10 and add to negative 3. Negative 5 and positive 2 works. Very nice. Not much that I can do with 4x squared, so we're just going to leave that for a second. Got another easy trinomial where a is equal to 1. So two things that multiply to 20 and add to negative 9. Negative 5 and negative 4 fit. Yes, very good. Okay, we are going to start a little restrictions list down at the bottom here. So anything in the denominator,
5.
all of these, they need to be restricted. So Zach says 5. Negative 2 is one of them, yes.
4.
And 4, lovely. Okay, now because this is a division question, we are going to flip and multiply the second fraction.
And put 0 as well there after.
Yes, and then we'll have to add to our restrictions list.
We have to wait everything out again.
Life is hard, eh?
Yeah.
Okay, so Zach suggested that we add 0 to our list here because now we have 4 times x squared And 4 times something to be 0, that would just mean that the x would be 0, right? 4 times 0 squared, that's 0. So there's all of our restrictions there. And then we'll start canceling. I personally prefer to write the list of restrictions before I start canceling, just so that I don't miss anything. So just be mindful about that. Does anyone see anything now that can be reduced? Cameron? The x minus 5s, for sure.
4 and 2.
Oh, 4 and 2, that's good. So that will reduce to 1 and 2.
The x's as well. So
And the x's, yes. So a single x here with one of the x's and the x squared. So I'll just cancel out the squared there. Okay. So x minus 4 times x minus 4. The simplest way we can write this is x minus 4 squared.
Yeah.
Okay, and then on the bottom, we have an x times x plus 2. Oh, a 2x times x plus 2, actually. Is there anything else that we're missing that can be canceled out here? Did we miss anything? How about the 4 here and the 2? Why not, Lauren? Ah, okay, there's a minus right next to that, so we can't cancel out anything there. Same with x and x, right? They're both next to pluses and minuses, so we definitely don't want to cancel those.
So
Okay?
we're finished.
So we are finished, that's right. Any questions?